for this series of videos is going to be Grade 11 Analytical Geometry. The first thing you need to remember are the formulae that you did in Grade 10. The length of a line segment is the difference between your x's squared plus the difference between your y's squared. Essentially, you're really using the theorem of Pythagoras. The gradient of a line, difference in y over difference in x. The midpoint, average your x's, average your y's. The equation of a straight line, y equals mx plus c. If you have parallel lines, your gradients are the same, and if you have perpendicular lines, the product of the gradients is going to be -1. The other work that you need to know from grade 10 is when you're dealing with quadrilaterals, four-sided figure, all your angles total 360 degrees. Start making your quadrilateral a bit special. One pair of opposite sides parallel gives you a trapezium. Two pairs of opposite sides gives you a parallelogram, and then you are expected to know all the properties of a parallelogram. Opposite sides are equal, opposite angles are equal, the diagonals bisect each other, and if you were using any of those to prove a parallelogram, you could also prove that you've got a parallelogram if one pair of opposite sides are both equal and parallel. A parallelogram can be special in one of two ways. If all the angles are equal, they're going to be 90, so you have a rectangle where the diagonals are equal in length. If all the sides are equal, you have a rhombus, and the other properties of a rhombus you need to remember are the diagonals bisect at 90 and the diagonals bisect the angles of the rhombus. A kite has two pairs of adjacent sides equal. The diagonals intersect at 90, but only one of the diagonals of a kite is bisected. Right, so now we're going to do a couple of examples just using your basic grade 10 analytical geometry. The first thing we're asked to work out is the length of AB. So AB squared is just going to be equal to the difference between your x's squared, -4 minus 0, plus the difference between your y's squared. Gives us 16 plus 4, 20. Therefore, the length of AB is the square root of 20, and in simplest third form, 20 is 4 times 5, so you can write that as 2 root 5. The gradient of BC. For the gradient of BC, we are going to say the difference in y, 4 minus 4, all over the difference in x, 2 minus 0. You land up with 8 over 2. Your answer is 4. Now, E is some 0.10, and the question is, really, is it going to lie on BC? So the trick here is to have a look at the gradient of BC. We already know that that is 4. And then also to calculate the gradient of CE. So the gradient of CE is going to be 4 minus 0 all over 2 minus 1. 4 over 1, which is 4. Because C is a common point and BC has the same gradient as CE, we can deduce that B, C, and E are collinear. Next question, is angle B equal to 90 degrees? Well, the easiest thing to do to check if you've got a right angle is to work out the gradient of BC and the gradient of AB. We already have the gradient of BC, so now we want the gradient of AB. So we're going to take -2 minus -4 all over -4 minus 0. Minus 2 plus 4 is 2. divided by minus 4, the gradient of AB is going to be minus a half. If we compare this with the gradient of BC, okay, the gradient of BC multiplied by the gradient of AB becomes 4 times minus a half, which is not equal to minus 1. Therefore, angle B in this case is not equal to 90 degrees. The last question here is, we are told that ABCD is a parallelogram, and we have to find the coordinates of that last vertex point D. There are a couple of ways of doing it. You can use your opposite sides parallel, your opposite sides equal in length, but the easiest property to use is the fact that if it's a parallelogram, your diagonals bisect each other. In other words, the midpoint of AC has to equal the midpoint of DB. So the midpoint of AC, we have minus 4 plus 2 over 2, minus 2 plus 4, and it must equal the midpoint of BD, x plus 0 over 2, y plus minus 4 over 2. Minus 4 plus 2 is minus 2 over 2, gives us a value of negative 1. Minus 2 plus 4 over 2 gives me a value of 1. Here I get x over 2, and that is y minus 4 over 2. And those two ordered pairs are equal to each other. Now, if ordered pairs are equal to each other, it just means the x-coordinate equals the x-coordinate. So minus 1 is equal to x over 2. In other words, x is equal to negative 2. And I should say, the y-coordinate of 1 equals y minus 4 over 2. 2 is equal to y minus 4. My y value is 6. Therefore, the coordinates of this point D are going to be minus 2 and 6.